Provide a counter example to justify each of the following false statements. Okay, in number 6 we got, if a system of linear equations has no free variable, so we want to create with no free variables, then it has a unique solution. So we need to disprove this. Unique solution means we can either have no solution or infinitely many solutions. So system with no free variables, so let's write down its augmented matrix 1 2 1 2, so no free variable, right? So first, second, and we have 3, and here is 0 3 5. So no free variables, but at the same time we can have sometimes 0 0 1 or any other number. So there are no free variables. Okay, for both columns we got some type of pivots, but due to the last, no solution. Okay, I mean, this would be true if the system was consistent. The equation has the trivial solution if and only if there are no free variables. So if there are no free variables, so let's do a system with free variable and we want to show it's got trivial solution. Okay, so in fact, whether there are free or no free variables, this has always the trivial solution. So we're going to write augmented matrix for a system with free variable 1 2, and we have 0 here, 0 0 0, let's say 0 because we have 0 here. So we got free variable, okay, and system with free variable. But this one, if we try to solve, x plus 2y equals 0 and xy equals 0 0 solves this equation. So for this system, in fact, ax equals 0, we call a homogeneous system. It's got always the trivial solution regardless of free variable or no free variables, by the way. Okay, that's the case. We are not saying only trivial solution. We are not saying that part. Here the equation is consistent if the augmented matrix has a pivot position in every row. Okay, if the augmented matrix, so we want to assume this part, augmented matrix with pivot position in every row. So for whole thing, a b, not only a b, and we want to show ax plus b inconsistent. Okay, so pivot position in every row, so 1 2, now b is 3. So now when we are considering augmented matrix. Okay, so the whole thing. So inconsistent means you can always do 0 1, let's say 4. So pivot 0 0 1 here, or any other number has a pivot here. Okay, I'm just separating this, but this is not there. So due to this pivot here, pivot here, pivot here, so we got for this AB, not only AB has pivot in each row, but this system is inconsistent because in the last, from the last we get 0 equals 5. This is inconsistent, no solution. Okay, if the augmented matrix has a pivot position in every row, it's a pretty much, it's the same thing. If this one is given, so we want to have this with pivot position in each row. Now we want to show the equation is inconsistent. we showed that, but now this time we want to make it consistent. Okay, then you can just say 1 2 3 every row, right? Then 0 1 2. Now we got two rows. Here is pivot, here is pivot, so we got pivot in each row, and this equation is in fact consistent because this is y equals 2 x plus 2y equals 3, so this is consistent. So from these two examples, as you can imagine, the pivot position in each row of AB has nothing to do with the system being inconsistent or consistent. Okay, if the question says consistent, we can clearly make inconsistent system. If it is asking inconsistent, then we can make it consistent as well. Now number 10, if x is a non-trivial solution of this, okay, then every entry is non-zero. Okay, non-trivial solution, then every entry is non-zero. So every entry, so we want to show some entries are zeros. So I mean this one, yeah, this one is non-trivial, still every entry is some of the entries are zero. So let's come up with some examples. So we want y and z 0 and something like this. Okay, every entry is non-zero. We can have just two of them. So x is a non-trivial solution of this. Okay, we don't have to even write any system, because we can just say x equals 1 0 is a non-trivial, because not 0 0 is non-trivial solution, but each entry is not non-zero. One entry is 0, right? So this one would do it.